Have you ever wondered what might be gliding through the dark spaces between worlds, heading our way with silent purpose? Tonight, we're drifting into one of the most intriguing mysteries of our solar system, a tale that begins with a visitor from beyond the edges of our cosmic neighborhood. This is the story of three, I/ATLAS, and the question that's been keeping astronomers awake at night. Could this interstellar wanderer be part of something much larger than we first imagined? I'm your host for this gentle journey through the cosmos, where we explore the universe one curious thought at a time. Whether you're settling in for the evening or finding a quiet moment to ponder the mysteries above, I hope this exploration brings you both wonder and peace. If you're new to our community of cosmic contemplators, welcome aboard this sleepy voyage through space and time. Before we venture into the depths of this astronomical puzzle, I'd love to know where you're joining us from tonight. Are you watching from a quiet apartment in Tokyo as the city lights flicker below, or perhaps from a cozy corner in Copenhagen where snow might be gently falling? Drop a comment and let me know what time it is in your corner of our shared world. There's something beautiful about knowing our little community is scattered across the globe, all looking up at the same stars, all wondering about the same cosmic mysteries. Now, settle back into your most comfortable position. Let your shoulders drop, your breathing slow, and your mind open to possibilities that stretch far beyond our everyday concerns. What we're about to explore tonight might challenge what you think you know about visitors from deep space, but don't worry about remembering every detail. Just let the ideas wash over you, like starlight through a bedroom window. And as always, remember that this video is purely for educational and relaxation purposes. We're here to explore, to wonder, and perhaps to drift off with thoughts of the cosmos dancing in our minds. So, what exactly is 3I/ATLAS? And why should we care about one small object drifting through the vastness of space? The story begins with a discovery that sent ripples through the astronomical community, not because of what was found, but because of what it might represent. Picture this. Somewhere in the cold depths between star systems, far from the warming influence of any sun, objects drift in the cosmic dark. These are the wanderers, the nomads of space, following paths carved by gravity and momentum across distances so vast that light itself takes years to bridge them. Most of these travelers remain invisible to us, too small and too distant to catch even in our most powerful telescopes. But occasionally, very rarely, one of these cosmic drifters ventures close enough to our solar system for us to notice. That's exactly what happened when 3I/ATLAS was spotted by the Asteroid Terrestrial Impact Last Alert System, the sky-watching network that gave this mysterious visitor its name. The discovery itself was routine enough, just another point of light moving against the starfield, another entry in the endless catalogue of objects that populate our cosmic neighborhood. But as astronomers began to study this new arrival more closely, something unusual emerged from the data. 3I/ATLAS wasn't behaving quite like the typical chunks of rock and ice that occasionally visit from the outer reaches of our solar system. Its trajectory, its brightness, the way it responded to the sun's warmth, all painted a picture of something different. This wasn't just another comet or asteroid that had wandered in from the Kuiper Belt or the Oort cloud. The orbital calculations told a clear story. This object had come from somewhere else entirely, from the vast spaces between the stars. This made 3I/ATLAS only the third confirmed interstellar visitor we've ever detected entering our solar system. The first was Oumuamua, that strange, elongated object that zipped through in 2017 and left us with more questions than answers. The second was 2I/Borisov, a more comet-like visitor that behaved largely as expected. And now we had 3I/ATLAS, adding another chapter to our still brief encounters with travelers from beyond our solar system's borders. But here's where the story takes an intriguing turn. where the ordinary becomes extraordinary. As researchers continued to track and study 3I/ATLAS, some began to notice patterns that suggested something remarkable. What if this wasn't just a single, lonely traveler making a chance encounter with our solar system? What if it was part of something much more significant? The idea emerged gradually, pieced together from observations and calculations that painted an increasingly compelling picture. Scientists began to wonder whether 3I/ATLAS might be leading what could be described as a fleet, a stream of objects all originating from the same distant source, all following roughly similar paths through the galaxy, all potentially heading in our general direction. This wasn't the stuff of science fiction movies with their dramatic fleets of alien spacecraft. Instead, it was something more subtle, but perhaps equally profound. The possibility that our solar system was about to experience an encounter with a stream of interstellar objects, a cosmic parade of visitors that could give us unprecedented insights into the nature of other star systems and the materials that drift between them. The concept isn't entirely without precedent. Astronomers have long known that space isn't empty, that the regions between stars contain countless objects, from tiny grains of dust to massive rogue planets that were ejected from their birth systems eons ago. These objects don't travel alone. They move in streams and clusters, following the gravitational currents that flow through our galaxy like invisible rivers. When a star system forms, it's a messy, chaotic process. Not everything gets swept up into planets and moons. Vast amounts of material get scattered, some of it flung out into interstellar space by the gravitational dance of forming worlds, or by close encounters with other stars. These ejected materials don't disappear. They become part of the galaxy's nomadic population, wandering between the stars for millions or billions of years. Occasionally, these wandering streams intersect with other star systems. It's like cosmic ships passing in the night, except the encounter can last for thousands of years, as object after object from the stream makes its way through the visited system. For us, such an encounter would be like receiving a detailed package from another star system, a collection of samples that could tell us about conditions and processes in parts of the galaxy we'll never directly explore. The evidence for 3I/ATLAS being part of such a stream comes from several sources. First, there's its trajectory and velocity. When astronomers traced its path backward through space and time, they found indications that it might share a common origin with other objects we've detected or might detect in the future. The mathematics of orbital mechanics are precise, and they can reveal whether objects that appear to be traveling independently might actually be part of a larger group that was dispersed over time. Then there's the timing. 3I/ATLAS didn't arrive in isolation. Its discovery came during a period when our detection capabilities had improved dramatically, when new sky surveys were scanning the heavens with unprecedented thoroughness. Some researchers suggested that we might be seeing the first members of a stream that's been invisible to us until now, simply because we lacked the tools to spot such faint, distant objects. The implications are staggering to consider. If 3I/ATLAS is indeed leading a fleet of interstellar visitors, we might be on the verge of the greatest natural experiment in comparative planetology ever conducted. Each object in such a stream would be a messenger from its origin system, carrying with it information about the conditions, chemistry, and history of its birthplace. Imagine studying dozens or even hundreds of objects from the same distant star system, each one offering a different piece of the puzzle. Some might be rocky, others icy. Some might show signs of having once been part of larger bodies, while others might be pristine remnants of the original stellar nursery. Together, they could paint a detailed picture of how other star systems form and evolve, information that would revolutionize our understanding of planetary science and our place in the galaxy. But there's also something profoundly humbling about this possibility. It reminds us that our solar system isn't isolated, that we're part of a vast, interconnected galaxy where materials and objects flow between stars like leaves carried on cosmic winds. The iron in our blood, the calcium in our bones, the oxygen we breathe, all of it was forged in the hearts of dying stars and scattered across the galaxy. Now it seems we might be receiving visitors that could tell us about the stellar forges that created them. The question of whether 3I/ATLAS is truly leading such a fleet remains open, a mystery that will likely unfold over the coming years and decades. Our telescopes continue to scan the skies, searching for additional objects that might share its origin and trajectory. Computer models run countless simulations, trying to predict when and where the next visitors might appear. Some researchers are optimistic, pointing to the increasing frequency of interstellar object discoveries as evidence that we're entering a new era of cosmic encounters. Others urge caution, reminding us that space is vast and that chance encounters with solitary wanderers might be more common than we previously thought. What's certain is that 3I/ATLAS has already changed how we think about our place in the galaxy. It's a reminder that the universe is full of travelers, that the space between stars isn't empty, but alive with motion and possibility. Whether it's leading a fleet or wandering alone, it represents a connection to distant worlds, a bridge between our small corner of the cosmos and the vast, largely unexplored galaxy beyond. As we continue to track this mysterious visitor and search for any companions it might have, we're participating in one of humanity's greatest adventures, the exploration of the unknown. Each new discovery, each refined calculation, each improved observation brings us closer to understanding not just 3I/ATLAS, but the nature of our cosmic neighborhood and our place within it. The story of 3I/ATLAS is still being written, unfolding in observatories and research centers around the world. It's a story of discovery and wonder, of questions that lead to more questions, of the endless human drive to understand the mysteries that surround us. The gentle dance of discovery continues as we delve deeper into what makes 3I/ATLAS such a compelling mystery. While our cosmic visitor drifts through the outer reaches of our solar system, astronomers around the world are piecing together clues that might reveal whether this solitary wanderer is truly alone or part of something far more extraordinary. To understand why the possibility of a fleet matters so much, we need to step back and consider how rare these encounters really are. Think of our galaxy as a vast ocean, with star systems scattered like islands separated by immense stretches of seemingly empty water. But just as Earth's oceans teem with life invisible from the surface, the spaces between stars are populated by countless objects, most too small and distant for us to detect. The journey of an interstellar object is almost incomprehensibly long. 3I/ATLAS has been traveling through the galaxy for perhaps millions of years, crossing distances so vast that our entire recorded history would be just a brief moment in its voyage. During this time, it has experienced temperatures near absolute zero, radiation from cosmic rays, and the subtle gravitational tugs of distant stars. It's a survivor, a cosmic time capsule that has endured conditions no human-made object has ever faced. What makes astronomers particularly excited about 3I/ATLAS is not just its interstellar origin, but the possibility that its arrival might signal the beginning of a much larger event. Imagine, if you will, a river of objects flowing through space, all originating from the same distant stellar system, all following roughly parallel paths carved by ancient gravitational encounters. Such streams exist throughout our galaxy, invisible highways of cosmic debris that occasionally intersect with star systems like ours. The evidence for this fleet hypothesis comes from multiple sources, each piece adding to a picture that grows more intriguing with every observation. First, there's the trajectory analysis, When scientists trace 3I/ATLAS's path backward through space and time, they find hints that it might share a common point of origin with other objects that could still be en route. The mathematics are complex, involving calculations that account for the gravitational influences of every major body in our solar system. But the preliminary results are tantalizing. Then there's the question of composition. Spectroscopic analysis of 3I/ATLAS reveals details about what it's made of, information that can tell us about the conditions in its birth system. If additional objects arrive with similar compositions, it would strengthen the case that they all came from the same place. Conversely, if future visitors show dramatically different characteristics, it might suggest that we're dealing with unrelated wanderers from various corners of the galaxy. The timing of 3I/ATLAS's discovery is also significant. Our ability to detect such objects has improved dramatically in recent years, thanks to advances in telescope technology and sky survey programs. Projects like the Catalina Sky Survey, Linear and Neowise scan the heavens continuously, searching for anything that moves against the background of stars. It's possible that streams of interstellar objects have been passing through our solar system for millennia, but we simply lack the tools to notice them. This raises a fascinating question. How many cosmic visitors have we missed over the years? How many messengers from distant worlds have slipped through our solar system undetected, carrying with them secrets about their origins that we'll never know? The thought is both humbling and exciting, a reminder that the universe is far more active and interconnected than we once believed. If 3I/ATLAS is indeed the harbinger of a larger stream, the implications extend far beyond astronomy. Each object in such a fleet would be a natural laboratory, a sample of materials and conditions from another star system delivered directly to our cosmic doorstep. By studying these visitors, we could learn about the formation and evolution of planetary systems across the galaxy, gaining insights that would take centuries of interstellar travel to obtain directly. Consider what we might discover. Objects from a young, active star system might bear the chemical signatures of recent stellar formation, rich in the heavy elements forged in supernovae. Visitors from an ancient system might show signs of billions of years of cosmic weathering, their surfaces altered by eons of radiation and micrometeorite impacts. Some might even carry organic compounds, the building blocks of life, giving us clues about the potential for biology in distant worlds. The possibility becomes even more intriguing when we consider that different objects in the stream might have originated from different parts of their birth system. Some could be fragments of rocky planets, blasted into space by catastrophic impacts. Others might be chunks of icy moons, carrying within them traces of ancient oceans. Still others could be pieces of the original stellar nursery, pristine materials that have remained largely unchanged since the system's formation. But there's something else to consider, something that adds an almost poetic dimension to this cosmic mystery. If 3I/ATLAS is part of a stream, then our solar system is about to experience something like a celestial parade, a procession of visitors from another world passing through our neighborhood over potentially thousands of years. Each arrival would be an event, an opportunity to study materials from the same distant source, but perhaps formed under slightly different conditions. The search for additional members of this potential fleet has already begun in earnest. Astronomers are combing through existing data, looking for objects that might have been overlooked or misclassified. They're also training their instruments on the regions of sky where theory predicts the next visitors might appear. The work requires patience and precision, as these objects are typically very faint and can easily be mistaken for more mundane asteroids or comets until their trajectories are carefully analyzed. Advanced computer simulations are playing a crucial role in this search. By modeling the dynamics of how object streams disperse over time, researchers can predict where and when future visitors might become visible. These models account for the complex gravitational environment of our solar system, the subtle perturbations caused by the giant planets, and the long-term effects of stellar encounters that might have occurred during the stream's journey through the galaxy. The international nature of this investigation is particularly striking. Observatories around the world are coordinating their efforts, sharing data and observations in real time. Ground-based telescopes in Chile scan the southern sky, while their counterparts in Hawaii monitor the north. Space-based observatories add their unique perspectives, free from the blurring effects of Earth's atmosphere. It's a global effort to understand a phenomenon that connects us to the broader galaxy. Amateur astronomers are also contributing to this cosmic detective story. With increasingly sophisticated equipment and software, dedicated skywatchers around the world are discovering new objects and helping to track known ones. The possibility that 3I/ATLAS might be part of a larger phenomenon has energized this community, adding urgency and excitement to their nightly vigils. As we wait for more data and additional discoveries, 3I/ATLAS continues its journey through our solar system. It's currently moving away from the Sun, growing fainter with each passing day as it heads back toward the interstellar medium from which it came. But even as this particular visitor fades from view, the questions it has raised remain vibrant and compelling. The story of 3I/ATLAS reminds us that we live in a dynamic galaxy, one where materials and objects flow between star systems, like currents in a vast ocean. Our solar system isn't an isolated island, but part of an interconnected cosmic ecosystem. The possibility that we're about to receive multiple visitors from the same distant source is both scientifically thrilling and philosophically profound. Whether 3I/ATLAS is truly leading a fleet or traveling alone, its presence has already enriched our understanding of the galaxy we inhabit. It represents a connection to distant worlds, a tangible link to processes and events that occurred far from our Sun. In studying this wanderer, we're not just learning about a single object, but about the nature of stellar systems and the vast spaces that separate them. The gentle mystery of 3I/ATLAS continues to unfold, each new observation adding depth to our understanding while simultaneously raising new questions. It's a reminder that the universe is full of surprises, that even in our seemingly quiet corner of the galaxy, we can encounter wonders that challenge our assumptions and expand our horizons. As we drift off to sleep tonight, we can take comfort in knowing that somewhere out there, cosmic messengers are carrying stories from distant worlds. And occasionally, just occasionally, they choose to share those stories with us. The implications of what 3I/ATLAS might represent extend into realms that stretch our imagination in the most wonderful ways. As this mysterious visitor continues its path through our solar system, scientists are beginning to consider scenarios that would have seemed like pure fantasy just decades ago. What if the stream of objects potentially following 3I/ATLAS contains not just rocky debris or icy fragments, but something far more intriguing? Picture, if you will, the birth of a star system much like our own, but perhaps orbiting a different type of star, under different conditions, with different chemical abundances. In such a system, the processes that shaped planets and moons might have unfolded in ways both familiar and alien to us. The objects ejected from such a system during its chaotic youth would carry within them the signatures of these unique conditions, like cosmic DNA samples waiting to be decoded. Some researchers have begun to speculate about what they call the archaeological potential of interstellar visitors. Each object that arrives from the same source system would be like an artifact from a distant civilization of worlds, not necessarily harboring life, but certainly telling stories about environments and processes we've never directly observed. The chemistry preserved in these wanderers could reveal whether their birth system had the right conditions for organic complexity, whether liquid water might have existed on ancient worlds, whether the building blocks of life as we know it had the chance to assemble and evolve. But the mystery deepens when we consider the sheer scale of what we might be dealing with. If 3I/ATLAS truly is the vanguard of a larger stream, the number of objects potentially heading our way could be staggering. Computer models suggest that such streams can contain thousands, perhaps even millions of objects of various sizes. Most would be too small to detect with current technology, mere pebbles and dust grains that would pass through our solar system unnoticed. But among them might be dozens or even hundreds of larger objects, each one a potential treasure trove of information about distant worlds. The timing of these arrivals presents another fascinating puzzle. Unlike the predictable orbits of comets from our own solar system, interstellar visitors follow trajectories shaped by the complex gravitational environment of the entire galaxy. Their arrival times can be spread across centuries or millennia, creating what astronomers sometimes describe as a slow-motion fireworks display of cosmic proportions. This extended timeline means that the story of 3I/ATLAS and its potential companions is one that will unfold across generations. Children born today might grow up to study objects that are just now beginning their final approach to our solar system. The data we collect from 3I/ATLAS will serve as a baseline for comparison with future visitors, allowing us to build an increasingly detailed picture of their shared origin. The technological challenges of studying such a fleet are immense, but not insurmountable. Each interstellar visitor presents a brief window of opportunity when it's close enough and bright enough for detailed observation. During these precious months or years, astronomers must gather as much information as possible using every available technique. Spectroscopy reveals composition. Photometry tracks changes in brightness that might indicate rotation or outgassing, and radar can sometimes provide details about size and shape. Future space missions might even attempt to intercept and study these visitors up close. The European Space Agency and NASA have both proposed concepts for rapid response spacecraft that could be launched to rendezvous with newly discovered interstellar objects. Such missions would require revolutionary propulsion technologies and precise navigation, but the scientific rewards would be extraordinary. Imagine bringing back actual samples from another star system, materials that formed around a different sun and travelled for millions of years to reach us. The philosophical implications are equally profound. If 3I/ATLAS is indeed leading a procession of cosmic messengers, it changes our relationship with the galaxy in fundamental ways. We're no longer passive observers looking out at distant stars and wondering what lies beyond. Instead, we become active participants in a galactic exchange program, receiving visitors and samples from worlds we may never directly explore. This perspective transforms our understanding of isolation and connection on cosmic scales. The vast distances between stars no longer seem quite so insurmountable when we realize that materials and objects regularly flow between stellar systems. We're part of a larger community, connected by the slow but steady exchange of cosmic debris that carries information about conditions and processes throughout our galactic neighborhood. The cultural impact of such discoveries extends far beyond the scientific community. The idea that we're receiving visitors from other star systems, even if they're just chunks of rock and ice, captures the imagination in ways that abstract discussions of exoplanets and stellar evolution cannot. These are tangible objects we can study and touch, physical links to distant worlds that make the universe feel less vast and more interconnected. Artists and writers have already begun to explore the poetic dimensions of interstellar visitors. There's something deeply moving about objects that have travelled for millions of years across the cosmic dark, surviving temperatures near absolute zero and bombardment by cosmic radiation, only to arrive in our solar system just as humanity has developed the tools to recognize and study them. It's as if the universe has been preparing a gift for us, timing its delivery to coincide with our coming of age as a spacefaring species. The educational opportunities presented by 3I/ATLAS and its potential companions are equally exciting. Students around the world can participate in tracking and analysing data from these visitors, contributing to real scientific research while learning about astronomy, physics, and planetary science. The story provides a perfect framework for discussing concepts like orbital mechanics, spectroscopy, and the formation of stellar systems, all grounded in the concrete reality of objects we can observe and study. Amateur astronomers are finding themselves at the forefront of this cosmic detective story. With increasingly sophisticated equipment becoming available to non-professionals, dedicated skywatchers are making important contributions to the search for additional interstellar visitors. The discovery of the next member of the potential fleet might well come from someone's backyard observatory, adding a democratic element to this grand scientific adventure. The international cooperation required to study these visitors is creating new models for how humanity approaches cosmic mysteries. Data-sharing protocols developed for tracking interstellar objects are being adapted for other astronomical projects. The rapid response networks established to coordinate observations of 3I/ATLAS are serving as templates for studying other transient phenomena. In many ways, these cosmic visitors are teaching us not just about distant star systems, but about how to work together as a global scientific community. As 3I/ATLAS continues its journey away from the Sun and back toward the interstellar medium, the questions it has raised continue to multiply. Each new piece of data adds depth to the mystery, while simultaneously opening new avenues of investigation. The possibility that it's leading a fleet of cosmic messengers has transformed our understanding of how star systems interact and evolve over galactic timescales. The gentle rhythm of discovery that characterizes modern astronomy means that answers to our questions about 3I/ATLAS will emerge slowly, piece by piece, observation by observation. Some mysteries may be resolved within years, while others might require decades of patient study. The potential fleet, if it exists, will reveal itself gradually, one visitor at a time, each arrival adding to our understanding, while raising new questions about the nature of interstellar space and the processes that shape planetary systems throughout the galaxy. In the quiet moments between observations, as telescopes scan the sky for signs of additional visitors, there's something profoundly peaceful about knowing that the universe is full of travelers, cosmic wanderers carrying stories from distant worlds. Whether 3I/ATLAS is alone or leading a grand procession, its presence reminds us that we live in a dynamic, interconnected galaxy where materials and information flow between stars like thoughts between minds. The story of 3I/ATLAS is ultimately a story about connection and discovery, about the slow but steady process by which humanity learns to read the messages written in starlight and cosmic dust. As we continue to study this mysterious visitor and search for any companions it might have, we're participating in one of the most fundamental human activities, the quest to understand our place in the vast, beautiful, and endlessly surprising universe that surrounds us. Tonight, as we drift deeper into this cosmic mystery, let's explore what makes the search for 3I/ATLAS's potential companions such a delicate and patient endeavour. Picture astronomers around the world, hunched over computer screens in the quiet hours before dawn, their eyes scanning streams of data for the faintest hints of movement against the stellar backdrop. Each night brings new observations, new measurements, new pieces of a puzzle that spans light years and millennia. The challenge of detecting interstellar visitors is almost poetic in its difficulty. These objects are typically no brighter than the faintest stars visible to the naked eye. Yet they're moving against a background of millions of much brighter celestial bodies. It's like trying to spot a single firefly drifting across a city skyline at midnight. Except the firefly might be thousands of times fainter, and the city stretches across the entire dome of the sky. What makes this search even more compelling is the realization that we're not just looking for rocks and ice. We're searching for time capsules, for fragments of worlds that formed under alien suns billions of years ago. Each potential member of the fleet carries within its frozen structure a record of conditions that existed in a stellar system we'll never visit. Chemistry that unfolded under circumstances we can only imagine. The patience required for this kind of astronomy is extraordinary. Unlike the instant gratification of most modern science, the study of interstellar visitors unfolds on timescales that can span human lifetimes. Graduate students who begin their careers tracking one visitor might still be analyzing data from its successors decades later, watching the slow revelation of an entire stellar system's history through the arrival of its scattered children. Consider the technological ballet required to study these cosmic wanderers. Ground-based telescopes in Chile's Atacama Desert peer through some of the clearest skies on Earth, their sensitive cameras capturing photons that have traveled for eons. Space-based observatories orbit high above our atmosphere, free from the turbulent air that blurs terrestrial observations. Radio telescopes listen for the subtle whispers of reflected signals bounced off these distant visitors, trying to discern their size and shape from the echoes that return. Each type of observation reveals different secrets. Optical telescopes show us how these objects reflect sunlight, revealing clues about their surface composition and structure. Infrared observations detect the faint heat they emit, telling us about their temperature and sometimes their internal composition. Spectroscopic analysis breaks their reflected light into component colors, creating a fingerprint that can reveal what elements and compounds exist on their surfaces. The story becomes even more intriguing when we consider how these observations must be coordinated across the globe. As Earth rotates, different observatories take up the watch, passing the cosmic baton from continent to continent. A telescope in Hawaii might track an object until dawn, then hand off to observatories in Europe as the sun sets there, which in turn pass the responsibility to facilities in Chile as their night begins. It's a planetary relay race, with humanity working together to maintain constant vigilance over our cosmic visitors. But there's something almost meditative about the way these discoveries unfold. Unlike the explosive revelations of particle physics or the rapid developments in biotechnology, astronomical discoveries often emerge gradually, like photographs developing in a darkroom. A faint smudge appears in one image, becomes clearer in the next, and slowly resolves into something recognizable and meaningful over weeks or months of careful observation. The computer algorithms that help identify potential interstellar visitors are marvels of pattern recognition. They must distinguish between the countless asteroids and comets native to our solar system and the rare visitors from beyond. The software looks for specific signatures, orbital characteristics that don't match anything bound to our sun, velocities that exceed the escape speed needed to break free from solar gravity, trajectories that trace back to the vast emptiness between stars. Yet even with these sophisticated tools, many discoveries still require the trained eye of experienced astronomers. There's an art to recognizing the subtle differences that mark an interstellar visitor, an intuition developed through years of studying how objects move through the solar system. Sometimes a single astronomer's hunch about an unusual observation leads to the confirmation of humanity's next cosmic guest. The data from 3 I/ATLAS continues to be analyzed and reanalyzed, each examination revealing new layers of information. Scientists are particularly interested in how the object's brightness changes over time, patterns that might indicate rotation or outgassing as it approaches and then recedes from the sun. These variations can tell us about the object's shape, its composition, and even its internal structure. Some researchers are focusing on the subtle gravitational perturbations that 3I/ATLAS experiences as it passes through our solar system. The giant planets, particularly Jupiter and Saturn, exert measurable influences on visiting objects, and these perturbations can be used to refine our understanding of the visitor's mass and density, its celestial mechanics at its most precise, using the gravitational dance of worlds to weigh objects too distant to study directly. The possibility that 3I/ATLAS might be part of a larger stream has led to intensive modeling efforts. Supercomputers run simulations that trace the evolution of object streams over millions of years, accounting for the complex gravitational environment of our galaxy. These models predict where additional members of the potential fleet might appear and when, creating target lists for telescopes around the world. But perhaps the most fascinating aspect of this search is how it's changing our understanding of the space between stars. What we once thought of as empty void is revealing itself to be a rich ecosystem of wandering objects, each one carrying information about stellar systems throughout our galactic neighborhood. The interstellar medium isn't empty. It's populated by countless travelers, most too small or distant for us to detect, but occasionally revealing themselves when they venture close to our solar system. The implications extend beyond pure science into realms of philosophy and wonder. If streams of objects regularly flow between star systems, then the galaxy is far more interconnected than we previously imagined. Materials forged around distant suns eventually make their way to other stellar systems, carrying with them the chemical signatures of their birthplaces. In a very real sense, we're all made of stardust, not just from our own stellar neighborhood, but potentially from across the galaxy. This interconnectedness becomes even more profound when we consider that our own solar system is undoubtedly contributing to these galactic streams. Objects ejected from our system during its chaotic early history are now wandering among other stars, perhaps occasionally visiting distant worlds, just as 3I/ATLAS is visiting ours. Somewhere in the galaxy, alien astronomers might be detecting visitors from our solar system, studying fragments of Earth's moon or Mars, trying to understand the conditions that existed around our sun billions of years ago. The timeline for resolving the mystery of 3I/ATLAS and its potential fleet extends far into the future. If additional objects are indeed following similar trajectories, they might arrive over the course of centuries or millennia. This means that the study of this potential stream will be a multi-generational endeavor, with discoveries made today forming the foundation for research that will continue long after we're gone. There's something beautifully humbling about participating in scientific investigations that span such vast timescales. The data we collect today will be analyzed by future researchers, using technologies we can't imagine, asking questions we haven't yet learned to formulate. Our observations of 3I/ATLAS are contributing to a story that will unfold across centuries, each generation adding new chapters to humanity's understanding of our place in the cosmic community. As we continue to monitor the skies for additional visitors, the search itself has become a form of cosmic meditation. Night after night, telescopes sweep across the star fields, their patient vigil a testament to humanity's enduring curiosity about the universe. Each observation is an act of hope, a quiet assertion that the cosmos has more surprises to reveal, more connections to discover, more stories to tell. The gentle rhythm of astronomical discovery means that answers to our questions about 3I/ATLAS and its potential companions will emerge slowly, like stars becoming visible as twilight deepens into night. Some mysteries may be resolved within our lifetimes, while others will require the patient work of future generations. But the search itself, with its combination of cutting-edge technology and timeless human curiosity, represents something beautiful about our species, our irrepressible desire to understand the universe that surrounds us. In the quiet hours between observations, as data streams in from telescopes around the world, there's something deeply peaceful about knowing that we're part of a cosmic conversation that spans the galaxy. Whether 3I/ATLAS is traveling alone or leading a grand procession of interstellar messengers, its presence in our solar system reminds us that we live in a universe full of travelers, wanderers, and stories waiting to be discovered. The mystery continues to unfold, one observation at a time, one calculation at a time, one quiet night of patient watching at a time. As we drift off to sleep tonight, we can take comfort in knowing that somewhere above us, cosmic visitors are carrying tales from distant worlds, and occasionally, just occasionally, they choose to share those tales with anyone curious enough to listen. Tonight, as we drift deeper into the quiet mystery of our cosmic visitor, let's explore what lies beyond the immediate question of whether 3I/ATLAS travels alone. The search for interstellar objects has revealed something profound about the nature of discovery itself, about how we learn to recognize the extraordinary hiding within the ordinary flow of celestial observations. Picture the moment when an astronomer first realizes they're looking at something truly special. It might begin with nothing more than a feeling, an intuition that develops after years of studying how objects move through space. The data looks almost normal at first glance, just another point of light drifting against the star field. But something doesn't quite fit the expected patterns. The trajectory seems unusual, the velocity slightly too high, the orbital characteristics just different enough to warrant a second look. This is how most interstellar visitors announce themselves, not with dramatic fanfare, but with subtle whispers that only trained eyes can recognize. 3. I/ATLAS followed this quiet pattern of revelation, initially catalogued as just another routine discovery before its true nature became apparent through careful analysis. The mathematics of its orbit told the real story, revealing velocities that exceeded the escape speed needed to break free from our sun's gravitational embrace. What makes the study of these visitors so compelling is how they challenge our assumptions about the space between stars. For centuries, we imagined the interstellar medium as a vast emptiness, a cosmic desert separating the oases of stellar systems. But each new interstellar visitor reveals that this supposed emptiness teems with travelers, wanderers carrying stories from distant worlds we'll never directly explore. The journey these objects undertake defies easy comprehension. 3I/ATLAS has been traveling through the galaxy for perhaps millions of years, experiencing temperatures that hover just above absolute zero, bombarded by cosmic radiation, subjected to the subtle gravitational tugs of passing stars. It's a testament to cosmic endurance, a fragment of another world that has survived an odyssey across the galaxy to arrive at our cosmic doorstep, just as humanity has developed the tools to recognize and study it. This timing feels almost miraculous when you consider the scales involved. The odds of any individual interstellar object passing through our solar system during the brief span of human civilization are astronomically small. Yet here we are, witnessing what may be the beginning of an extended encounter with materials from another star system. It's as if the universe has been saving these revelations for the moment when we were ready to appreciate them. The technology we use to study these cosmic messengers represents the culmination of centuries of astronomical development. Modern CCD cameras can detect individual photons that have traveled for eons, while sophisticated computer algorithms sift through millions of observations to identify the rare visitors from beyond our solar system. The precision required is staggering, like trying to measure the thickness of a human hair from a distance of several miles. Yet there's something beautifully human about how these discoveries unfold. Despite all our advanced technology, the moment of recognition often comes down to a single astronomer's trained intuition. someone who notices that an object's behavior doesn't quite match the expected patterns. It's a reminder that even in our age of automated sky surveys and artificial intelligence, the human element remains crucial to the process of discovery. The implications of studying interstellar visitors extend far beyond cataloguing cosmic debris. Each object that arrives from the space between stars carries with it information about processes and conditions in regions of the galaxy we'll never directly explore. They're natural space probes, launched not by any intelligence, but by the chaotic dynamics of stellar formation and evolution. Consider what we might learn from a detailed study of materials that formed around a different star. The isotope ratios could tell us about the nuclear processes that occurred in their birth system's stellar furnace. The mineral composition might reveal information about the original stellar nebula's chemistry. Surface features could provide clues about the object's history since leaving its home system, a record of millions of years spent wandering through interstellar space. Some researchers speculate that these visitors might even carry organic compounds, the basic building blocks of life as we know it. While the harsh conditions of interstellar space make the survival of complex molecules unlikely, simpler organic compounds might persist, protected within the object's interior. The discovery of such materials would provide unprecedented insights into the chemistry that occurs in stellar nurseries throughout the galaxy. The search for additional members of 3I/ATLAS's potential fleet has become a global endeavor, with observatories on every continent contributing observations and analysis. This international cooperation represents something beautiful about human nature, our ability to work together when faced with cosmic mysteries that transcend national boundaries. The data flows freely between research institutions, creating a real-time collaborative investigation that spans the globe. Amateur astronomers are playing an increasingly important role in this cosmic detective story. With access to sophisticated equipment and software that was once available only to professional observatories, dedicated skywatchers are making significant contributions to the search for interstellar visitors. The next member of the potential fleet might well be discovered by someone pursuing astronomy as a passion rather than a profession. The patience required for this kind of research is extraordinary. Unlike experiments that can be repeated in laboratory settings, astronomical observations must wait for the universe to provide opportunities. If 3I/ATLAS is indeed part of a larger stream, the next visitor might not arrive for years or even decades. Researchers must maintain their vigilance across timescales that can span entire careers, passing the torch of discovery from one generation to the next. This extended timeline adds a poetic dimension to the search. The data we collect today will be analyzed by future researchers using technologies we can't yet imagine. Our observations of 3I/ATLAS are contributing to a story that will unfold across generations, each new discovery building upon the foundation laid by previous investigations. The philosophical implications are equally profound. If streams of objects regularly flow between star systems, then our solar system is part of a vast, interconnected galactic ecosystem. Materials forged around distant suns eventually make their way to other stellar systems, creating connections that span both space and time. We're not isolated on our cosmic island, but part of a community of worlds linked by the slow but steady flow of interstellar debris. This perspective transforms how we think about our place in the universe. The calcium in our bones, the iron in our blood, the oxygen we breathe, all were forged in stellar furnaces and scattered across the galaxy by dying stars. Now it seems we're receiving samples from other stellar forges, cosmic care packages that tell us about conditions and processes in distant parts of our galactic neighborhood. The study of 3I/ATLAS and its potential companions is also revealing new truths about the dynamics of stellar systems. The processes that eject objects into interstellar space occurred during the chaotic early phases of planetary formation. when gravitational interactions between forming worlds scatter vast amounts of material beyond the reach of their parent star. These ejected fragments become cosmic nomads, carrying with them information about their birth system's youth. Our own solar system undoubtedly contributed to these galactic streams during its turbulent early history. Objects blasted from our neighborhood by ancient impacts or gravitational encounters are now wandering among other stars, perhaps occasionally visiting distant worlds, just as 3I/ATLAS is visiting ours. Somewhere in the galaxy, alien astronomers might be studying fragments that originated in our solar system, trying to understand the conditions that existed around our sun billions of years ago. The technology being developed to study interstellar visitors is pushing the boundaries of what's possible in observational astronomy. Rapid response spacecraft concepts could potentially intercept future visitors for close-up study, while ground-based observatories are being upgraded with ever more sensitive instruments capable of detecting fainter and more distant objects. Future missions might even attempt to collect samples from interstellar visitors, bringing back actual pieces of other star systems for detailed analysis in terrestrial laboratories. Such missions would require revolutionary advances in propulsion technology and precision navigation, but the scientific rewards would be extraordinary. Imagine holding in your hands a fragment of rock that formed around a different sun, that carries within its crystalline structure the story of alien worlds. The cultural impact of these discoveries extends far beyond the scientific community. There's something profoundly moving about the idea that we're receiving visitors from other star systems, even if they're just chunks of rock and ice. These tangible connections to distant worlds make the universe feel less vast and more intimate, reminding us that we're part of something much larger than our small corner of space. Artists and writers have begun exploring the poetic dimensions of interstellar visitors, finding inspiration in objects that have journeyed for millions of years across the cosmic dark to arrive at our doorstep. There's something deeply romantic about fragments of distant worlds choosing our moment in history to reveal themselves, as if the universe has been preparing gifts for us that are only now ready to be opened. The educational opportunities presented by 3I/ATLAS are equally exciting. Students around the world can participate in real research, analysing data from these cosmic visitors and contributing to our understanding of interstellar space. The story provides a perfect framework for discussing fundamental concepts in astronomy and physics, all grounded in the concrete reality of objects we can observe and study. As 3I/ATLAS continues its journey away from the Sun and back toward the interstellar medium, the questions it has raised continue to multiply and evolve. Each new piece of data adds depth to the mystery, while simultaneously opening new avenues of investigation. The possibility that it's part of a larger fleet has transformed our understanding of how star systems interact across galactic timescales. The gentle rhythm of astronomical discovery means that answers to our questions will emerge slowly, like stars becoming visible as twilight deepens into night. Some mysteries may be resolved within our lifetimes, while others will require the patient work of future generations. But the search itself represents something beautiful about our species, our irrepressible curiosity about the universe that surrounds us. In observatories around the world, telescopes continue their patient vigil, scanning the skies for signs of additional visitors from beyond our solar system. Each night brings new observations, new measurements, new pieces of a puzzle that connects us to the broader galactic community. Whether 3I/ATLAS is traveling alone or leading a procession of cosmic messengers, its presence has already enriched our understanding of the universe we inhabit. The story of 3I/ATLAS is ultimately about connection and wonder, about the slow process by which humanity learns to read the messages written in starlight and cosmic dust. As we continue to study this mysterious visitor and search for any companions it might have. We're participating in one of the most fundamental human endeavors, the quest to understand our place in the vast, beautiful, and endlessly surprising cosmos that is our home. Tonight, as we drift towards sleep with thoughts of cosmic travelers dancing in our minds, we can take comfort in knowing that the universe is full of wanderers, messengers carrying stories from distant worlds, and occasionally, just occasionally, they choose to share those stories with anyone curious enough to listen and patient enough to wait for their quiet revelations to unfold. The search for three I/ATLAS's potential companions has led researchers down pathways they never expected to explore. As we settle deeper into this cosmic mystery, let's consider the possibility that our understanding of interstellar visitors might be fundamentally incomplete. What if these objects aren't just random debris scattered by ancient stellar chaos, but part of something more organized, more purposeful in ways we're only beginning to comprehend? Picture the moment when astronomers first began to notice patterns in the data that didn't quite fit their models. It started subtly, with small discrepancies in trajectory calculations that seemed insignificant at first. But as more observations accumulated, these minor anomalies began to paint a picture that challenged everything we thought we knew about how objects move through interstellar space. The traditional model suggests that materials ejected from stellar systems during their formation scatter randomly throughout the galaxy, following paths dictated purely by gravitational forces and chance encounters. But what if the reality is more complex? What if there are organizing principles at work that we haven't yet recognized? Forces that can shepherd streams of objects across vast distances while maintaining some degree of coherence. This possibility emerged from careful analysis of three I/ATLAS's approach trajectory, when researchers traced its path backward through space and time, accounting for the gravitational influences of every star it might have encountered during its journey. They discovered something unexpected. The object's route showed signs of having been influenced by gravitational encounters that seemed almost too convenient to be coincidental. It's as if 3I/ATLAS had been guided along a path that would bring it directly into our solar system's sphere of influence. Not guided by intelligence, but perhaps by the subtle gravitational architecture of our galactic neighborhood, structures and patterns that we're only now beginning to recognize and understand. Consider the possibility that our galaxy contains what researchers are calling gravitational highways, invisible channels carved by the complex interplay of stellar masses and dark matter distributions. These cosmic roadways might funnel interstellar objects along preferred routes, creating streams that maintain their coherence across millions of years and countless light years of travel. If such highways exist, they would revolutionize our understanding of how materials move through the galaxy. Instead of random scattering, we might be dealing with a more organized system, one where objects follow predictable paths between stellar systems. The implications are staggering to contemplate. Such a system would mean that encounters like the one we're experiencing with three I/ATLAS aren't rare accidents but regular occurrences that happen whenever these gravitational highways intersect with star systems like ours. Our solar system might be positioned at a kind of cosmic crossroads, a place where multiple interstellar streams converge or diverge. The evidence for this hypothesis comes from several sources, each more intriguing than the last. First, there's the timing of recent interstellar discoveries. Oumuamua arrived in 2017, followed by 2I/Borisov in 2019, and now 3I/Atlas. While our improved detection capabilities certainly play a role in this apparent increase, some researchers wonder whether we're witnessing the beginning of a more sustained period of interstellar visitation. Then there's the question of directionality. When astronomers map the arrival vectors of known interstellar visitors, they find hints of patterns that shouldn't exist if these objects were truly scattered randomly throughout the galaxy. The angles and velocities suggest possible common origins or shared gravitational influences that guided their paths toward our solar system. The search for additional evidence has led to intensive reanalysis of astronomical data going back decades. Researchers are combing through old sky surveys, looking for objects that might have been misclassified or overlooked entirely. They're finding tantalizing hints of additional interstellar visitors that passed through our solar system before we had the tools to recognize them for what they were. Some of these retrospective discoveries are particularly intriguing. Objects that were initially catalogued as unusual asteroids or comets are being revealed as likely interstellar visitors when their orbits are recalculated using modern techniques. It's as if we've been receiving cosmic mail for years without realizing it. Letters from distant worlds that we mistook for local correspondence. The possibility that 3I/ATLAS might be part of a guided stream, rather than a random wanderer, adds layers of complexity to every observation. If the object is following a predetermined path carved by galactic gravitational structures, then predicting where its companions might appear becomes a matter of mapping these invisible highways rather than simply calculating random trajectories. This shift in perspective is already influencing how astronomers search for new interstellar visitors. Instead of scanning the entire sky uniformly, they're focusing their attention on regions where theoretical models predict these gravitational channels might direct incoming objects. It's a more targeted approach that could dramatically increase our chances of detecting additional members of the fleet. The technology required to map these potential gravitational highways pushes the boundaries of computational astronomy. Supercomputers must model the gravitational influences of billions of stars, accounting for their movements over millions of years, while incorporating the subtle effects of dark matter distributions that we can only infer from their gravitational signatures. These simulations reveal a galaxy far more structured than we previously imagined. Rather than stars scattered randomly through space, we see evidence of organization on scales that dwarf anything in our solar system. Stellar streams, dark matter filaments, and gravitational resonances create a complex web of influences that can shepherd objects across vast distances while maintaining some degree of predictability. The implications extend beyond astronomy into realms of philosophy and wonder. If the galaxy contains natural transportation networks that can guide objects between star systems, then the universe is far more interconnected than we ever dared imagine. Materials don't just scatter randomly into space, they follow paths that can eventually bring them to other worlds, other systems, other opportunities for discovery. This interconnectedness becomes even more profound when we consider that our own solar system is undoubtedly contributing to these galactic streams. Objects ejected from our neighborhood during its chaotic early history might be following these same gravitational highways, carrying samples of Earth's ancient past to distant stellar systems, where alien astronomers might one day study them with the same wonder we bring to investigating 3I/ATLAS. The timeline for understanding these potential highways extends far into the future. Even if the hypothesis proves correct, mapping the galaxy's gravitational architecture will require decades of observations and calculations. We're essentially trying to chart invisible roads that span thousands of light years, using only the occasional travelers we happen to detect as they pass through our cosmic neighborhood. But there's something beautiful about the patience this requires. Unlike the rapid pace of most modern science, astronomical discovery often unfolds on timescales that encourage contemplation and wonder. Each new observation adds a piece to a puzzle that will take generations to complete, creating a scientific legacy that connects us to future researchers we'll never meet. The search for 3I/ATLAS's companions has become more than just a hunt for cosmic debris. It's evolved into an investigation of the galaxy's hidden structure, a quest to understand the invisible forces that shape the movement of materials across interstellar space. Whether we're dealing with random wanderers or guided travelers, each new discovery adds to our understanding of how the universe operates on its largest scales. The cultural implications of these ideas are equally fascinating. The possibility that the galaxy contains natural highways connecting different stellar systems transforms our understanding of cosmic isolation. We're not alone on our cosmic island, cut off from the rest of the universe by vast emptiness. Instead, we're part of a connected network where materials, and perhaps even information, can flow between worlds along predetermined pathways. This vision of galactic connectivity has captured imaginations far beyond the scientific community. Artists and writers are exploring themes of cosmic unity and interconnection, finding inspiration in the idea that all stellar systems might be linked by invisible threads of gravitational influence. The universe becomes less cold and empty, more warm and connected when viewed through this lens of hidden highways and guided streams. Educational institutions are incorporating these concepts into their curricula, helping students understand that astronomy isn't just about cataloguing distant objects, but about recognizing the relationships and connections that bind the cosmos together. The story of 3I/ATLAS and its potential fleet provides a perfect framework for discussing how scientific understanding evolves, how new observations can challenge existing models, and lead to revolutionary insights. Amateur astronomers find themselves at the forefront of this cosmic detective story, their backyard observatories contributing crucial data to the search for additional interstellar visitors. The democratic nature of this research, where important discoveries can come from anywhere in the world, reflects something beautiful about how science works at its best. Curiosity and dedication matter more than institutional affiliation or expensive equipment. The international cooperation required to track these visitors continues to strengthen bonds between researchers across the globe. Data flows freely between observatories, creating a real-time collaborative investigation that transcends political boundaries. In studying these cosmic messengers, humanity demonstrates its ability to work together toward common goals that benefit all of our species. As 3I/ATLAS continues its journey away from our Sun, fading gradually as it returns to the interstellar medium from which it came, the questions it has raised grow ever more intriguing. Each new calculation refines our understanding of its trajectory and origin, while simultaneously opening new possibilities for what it might represent. The gentle rhythm of discovery that characterizes this field of research means that answers will emerge slowly, like photographs developing in a cosmic darkroom. Some questions might be resolved within years, while others will require the patient work of multiple generations. But the search itself has already transformed our understanding of the galaxy we inhabit. In observatories around the world, telescopes continue their vigilant watch, scanning predetermined regions of sky where theory suggests the next visitors might appear. Each night brings new data, new measurements, new pieces of a puzzle that connects our small corner of the cosmos to the vast galactic community beyond. The story of 3I/ATLAS reminds us that the universe is full of surprises, that even our most sophisticated models and theories must remain flexible enough to accommodate new discoveries that challenge our assumptions. Whether this mysterious visitor is a random wanderer or part of a guided fleet following ancient gravitational highways, its presence has already enriched our understanding of the cosmos we call home. Tonight, as we drift towards sleep with visions of cosmic highways and interstellar travelers filling our minds, we can take comfort in knowing that we live in a universe far more connected and organized than we ever dared hope. Somewhere out there, materials from distant worlds are following invisible paths that might one day bring them to our cosmic doorstep, carrying with them stories from stellar systems we'll never directly explore. The mystery continues to unfold, one observation at a time, one calculation at a time, one quiet night of patient watching at a time. Whether 3I/ATLAS is alone or leading a grand procession of cosmic messengers, its journey through our solar system represents a connection to something vast and wonderful. A reminder that we're part of a galactic community linked by forces we're only beginning to understand. In the gentle darkness between observations, as data streams in from telescopes around the globe, there's something deeply peaceful about participating in this cosmic conversation. We're listening to the universe tell its stories, patient enough to wait for revelations that might take years or decades to fully unfold, curious enough to keep asking questions even when the answers remain tantalizingly beyond our reach. The search for 3I/ATLAS's companions continues, guided by hope and wonder, driven by humanity's irrepressible desire to understand the beautiful, mysterious, and endlessly surprising universe that surrounds us. As we close our eyes tonight, we can drift off, knowing that somewhere above us, cosmic travelers are following ancient paths between the stars. And occasionally, just occasionally, those paths lead them to our small corner of the galaxy, where curious beings wait patiently to learn the secrets they carry from distant worlds. As we settle even deeper into this cosmic puzzle, let's consider what might happen if our theories about 3I/ATLAS prove correct. Picture a future where our night skies become windows into distant star systems, where each new interstellar visitor adds another piece to an ever-expanding map of galactic neighborhoods we'll never directly explore. The prospect of regular visits from cosmic messengers transforms how we think about our place in the universe. No longer are we isolated observers peering out at distant lights with little hope of understanding their true nature. Instead, we become participants in a grand exchange program, receiving samples and stories from worlds scattered across our galactic community. Imagine the archives that future astronomers might build from these encounters. Each visitor catalogued and studied, its composition analysed, its journey traced backward through space and time. These cosmic libraries would contain more information about stellar planetary evolution than we formation and could gather from centuries of telescope observations alone. We'd have actual pieces of other worlds to hold, to study, to understand in ways that light alone can never provide. The technological challenges of studying an entire fleet of interstellar visitors would push our capabilities to remarkable new heights. Current observatories, impressive as they are, were designed to track occasional cosmic wanderers, not to monitor a steady stream of visitors from beyond our solar system. The infrastructure required to study dozens or hundreds of interstellar objects would necessitate revolutionary advances in both ground-based and space-based astronomy. Consider the rapid response networks that would need to emerge. When a new visitor appears, astronomers would have only months or years to gather as much information as possible before it fades back into the cosmic dark. Teams around the world would need to coordinate observations with military precision, sharing telescope time and data in real time to maximize what we could learn from each brief encounter. The development of interception missions becomes not just possible but essential under such circumstances. Space agencies are already proposing concepts for spacecraft that could launch at short notice to rendezvous with newly discovered interstellar visitors. These missions would require revolutionary propulsion systems capable of matching velocities with objects traveling at tens of kilometers per second. Navigation systems precise enough to find targets smaller than mountains in the vastness of space. But perhaps the most profound implications would be philosophical rather than technological. If 3I/ATLAS truly represents the beginning of sustained contact with materials from other star systems, then humanity's relationship with the cosmos changes fundamentally. We're no longer alone with our questions about how planets form, how stellar systems evolve, how life might arise under different conditions. Each visitor would bring answers, but also new questions. A fragment of an ancient world might reveal chemical processes we've never observed. A chunk of ice from a distant comet could contain organic compounds that formed under alien conditions. Rocky debris might preserve magnetic signatures that tell us about the stellar winds that shaped its birth system billions of years ago. The educational revolution that would accompany such discoveries staggers the imagination. Students around the world could study actual samples from other star systems, holding in their hands materials that formed around different suns. The abstract concept of stellar nucleosynthesis becomes tangible when you can examine isotope ratios that differ from anything found in our solar system. Research institutions would need to develop entirely new fields of study. Comparative stellar archaeology might emerge, focusing on how different stellar environments influence planetary formation. Interstellar geology could develop as we learn to read the stories preserved in rocks that formed under alien conditions. The chemistry of distant worlds would become as real and immediate as the chemistry we study in terrestrial laboratories. The international cooperation required for such an endeavor would create unprecedented bonds between nations and institutions. When faced with a steady stream of cosmic visitors, each offering limited opportunities for study, competition would give way to collaboration. Data-sharing protocols would evolve into something approaching a global nervous system, with observations flowing instantly between observatories regardless of political boundaries. Amateur astronomers would find themselves integral to this global effort. The sheer number of objects requiring tracking would exceed the capacity of professional observatories alone. Backyard telescopes equipped with modern sensors could provide crucial observations, turning astronomy into a truly democratic science, where important discoveries might come from anyone with curiosity and clear skies. The timeline for such revelations extends far beyond our current lifetimes. If 3I/ATLAS is indeed part of a larger stream, the objects following it might arrive over centuries or millennia. This means we're potentially witnessing the beginning of humanity's longest-running scientific experiment, one that will span multiple generations and require institutional memory lasting longer than most civilizations. There's something beautifully humbling about participating in research that transcends individual human timescales. The data we collect today might not reach its full significance until analyzed alongside observations made by our great-grandchildren. We're planting seeds of knowledge that will grow in gardens we'll never see, contributing to understanding that will flourish long after we've returned to stardust. The cultural impact of regular interstellar visitation would ripple through human society in ways we can barely anticipate. Artists would find inspiration in objects that have traveled for millions of years to reach us. Writers would craft stories about the worlds these visitors left behind. Musicians might compose symphonies inspired by the rhythm of cosmic arrivals, each movement representing a different visitor from a different star. Religious and philosophical traditions would grapple with the implications of regular contact with materials from other worlds. What does it mean for our understanding of creation when we can hold fragments of planets that formed around different stars? How do we incorporate the reality of cosmic interconnectedness into worldviews that developed when we thought ourselves isolated in space? The economic implications are equally fascinating to contemplate. Industries would emerge around the study and analysis of interstellar materials. New technologies developed for space-based interception missions would find applications in terrestrial fields. The knowledge gained from studying alien chemistry and geology could revolutionize material science and lead to innovations we can't yet imagine. Yet perhaps the most profound change would be psychological. Humanity would no longer be able to think of itself as alone in the cosmos, not because we found signs of intelligence, but because we found undeniable proof that we're connected to the broader galaxy through the steady flow of materials between stellar systems. The universe would feel less vast and more intimate, less empty and more alive with possibility. The precision required to study these cosmic visitors would push measurement science to its absolute limits, analyzing samples smaller than grains of sand for isotope ratios that differ by parts per million, detecting organic compounds present in concentrations measured in parts per billion, reading magnetic histories preserved in crystals smaller than the width of human hair. These technical challenges would drive innovations that benefit fields far beyond astronomy. Medical diagnostics might advance through techniques developed for analyzing trace compounds in interstellar visitors. Environmental monitoring could improve through methods created for detecting subtle chemical signatures in cosmic samples. The ripple effects of such research would touch nearly every aspect of human knowledge. The storage and preservation of interstellar samples would become its own specialized field. Unlike terrestrial materials, these cosmic visitors would require protection from contamination by Earth-based compounds, while simultaneously being preserved for analysis by technologies that don't yet exist. Future researchers might need to study samples collected decades earlier using instruments we can't currently imagine. International agreements would need to evolve to govern the study and sharing of interstellar materials. Who owns a piece of another star system? How should such materials be distributed among research institutions? What protocols should govern the preservation of samples for future generations? These questions would require diplomatic solutions as complex as the science itself. The possibility that some visitors might contain organic compounds adds another layer of complexity to these considerations. If we discover materials' possibility of biology that suggests in other stellar systems, the implications would extend far beyond pure science. Protocols for handling potentially biologically active materials would need to be developed, even if the likelihood of actual biological contamination remains vanishingly small. As our understanding of interstellar visitors grows, we might begin to recognize patterns that reveal information about galactic structure itself. The chemistry and mineralogy of objects from different regions of the galaxy could map the distribution of elements forged in different stellar populations. We might learn to read the history of stellar formation and death written in the composition of cosmic wanderers. The search for three I/ATLAS's potential companions has already begun to change how we think about the galaxy we inhabit. Each night that telescopes scan predetermined regions of sky, we're participating in a form of cosmic archaeology, searching for artifacts from distant worlds that chose our moment in history to visit our corner of space. Whether this mysterious visitor travels alone or leads a grand procession of interstellar messengers, its journey through our solar system has already connected us to something vast and wonderful. We're no longer passive observers of a distant universe, but active participants in a galactic community linked by the patient flow of materials between stars. The gentle rhythm of discovery continues, one observation building upon another, each measurement adding depth to our understanding, while simultaneously revealing new mysteries to explore. In the quiet hours between observations, as data streams in from telescopes around the world, there's something deeply peaceful about knowing we're part of this cosmic conversation. Tonight, as we drift towards sleep with thoughts of interstellar highways and cosmic messengers filling our minds, we can take comfort in the knowledge that the universe is far more connected and alive than we ever dared imagine. Somewhere out there, materials from distant worlds follow ancient paths through space, and occasionally those paths bring them to our doorstep, carrying stories we're only beginning to learn how to read. The mystery of three. I/ATLAS continues to unfold, one patient observation at a time, reminding us that the most profound discoveries often emerge not with dramatic fanfare, but through the quiet accumulation of knowledge, the gentle persistence of curiosity, and the endless human capacity for wonder at the beautiful, interconnected cosmos we call home. As we continue our gentle journey through the cosmos tonight, let's drift into what may be the most intriguing aspect of this entire mystery. The question isn't just whether 3 I/ATLAS leads a fleet, but what such an encounter might mean for our fundamental understanding of how the universe operates on scales we've barely begun to comprehend. Picture yourself standing in a field on a clear winter night, looking up at stars that seem fixed and eternal. But what if those points of light were connected by invisible threads, pathways carved by forces so subtle that we've only recently developed the tools to detect them? The story of 3 I/ATLAS might be teaching us that the cosmos is far more organized, far more interconnected than our ancestors ever dared imagine. The mathematics behind these potential cosmic highways are elegant in their complexity. Imagine trying to map invisible roads that span thousands of light years, using only the occasional traveler you happen to spot as they pass through your neighborhood. It's like trying to understand the layout of a vast city by watching a few cars drive by your window, noting their directions and speeds, then attempting to reconstruct the entire street system from these limited observations. Yet that's exactly what researchers are attempting to do. They're using gravitational models that account for the positions and movements of billions of stars, incorporating the subtle influences of dark matter structures we can only detect through their gravitational effects. These simulations reveal a galaxy that's far from random, where invisible architecture guides the flow of materials across vast distances with surprising precision. The implications ripple outward like waves in a cosmic pond. If such pathways exist, then our solar system might be positioned at something resembling a galactic crossroads, a place where multiple streams of interstellar travelers converge or diverge according to gravitational choreography that's been unfolding for millions of years. We might not be experiencing a rare cosmic accident, but rather a predictable consequence of our location in this vast celestial web. Consider what this means for our understanding of planetary formation itself. If materials regularly flow between star systems along these invisible highways, then the elements that built our world might have originated not just from our local stellar neighborhood, but from across the galaxy. The carbon in our bodies, the oxygen in our atmosphere, the rare metals in our electronics, all might carry signatures of processes that occurred in stellar systems we'll never see. This interconnectedness becomes even more profound when we realize that our own solar system is undoubtedly contributing to these galactic streams. During its chaotic early history, gravitational encounters between forming planets scattered vast amounts of material beyond our sun's influence. Those ancient fragments of our cosmic childhood are now wandering among other stars, perhaps occasionally visiting distant worlds where alien observers might study them with the same wonder we bring to investigating 3I/ATLAS. The technology required to study such a system pushes the boundaries of what's currently possible. Imagine observatories designed not just to track individual objects, but to monitor entire streams of cosmic traffic flowing through our solar system. These facilities would need to operate continuously for decades or centuries, maintaining vigilance across timescales that dwarf human lifespans, while accumulating the vast data sets necessary to map galactic-scale structures. But perhaps the most beautiful aspect of this mystery lies in how it's changing our relationship with deep time. The visitors we're studying today began their journeys millions of years ago, when our solar system was young and Earth was still finding its geological rhythm. These objects have witnessed the galaxy's slow evolution, surviving conditions that would destroy any human-made technology, while carrying within their crystalline structures the memories of ancient worlds. Each potential member of 3I/ATLAS's fleet represents a time capsule from a different era of galactic history. Some might preserve materials from the early universe, when stellar nucleosynthesis was still enriching space with the heavy elements necessary for rocky planets. Others could carry signatures of more recent stellar events, supernovae, or stellar collisions that scattered processed materials across interstellar space. The patience required to study such phenomena reflects something profound about the nature of astronomical discovery itself. Unlike laboratory experiments that can be repeated at will, cosmic investigations must wait for the universe to provide opportunities. If additional members of the potential fleet are indeed following 3I/ATLAS, they might arrive over timescales measured in human generations, creating a multi-century research project that will connect astronomers across time in ways they never expected. This extended timeline adds a poetic dimension to the entire endeavor. Graduate students who begin their careers studying the data from 3I/ATLAS might spend their entire professional lives analyzing information from subsequent visitors, each new arrival adding depth to theories developed decades earlier. The research becomes a conversation between generations, with discoveries made today forming the foundation for insights that won't emerge until our great-grandchildren have taken up the work. The international cooperation required for such long-term studies is creating new models for how humanity approaches cosmic mysteries. Observatories on every continent are contributing observations and analysis, sharing data in real time across political boundaries that seem increasingly irrelevant when faced with questions that span galactic distances. The flow of information mirrors the flow of cosmic materials, connecting human minds across Earth, just as gravitational forces connect stellar systems across the galaxy. Amateur astronomers find themselves uniquely positioned to contribute to this ongoing investigation. The sheer number of objects that might require tracking could exceed the capacity of professional facilities, making backyard observatories essential components of a global monitoring network. The next significant discovery might well come from someone pursuing astronomy as a passion rather than a profession, armed with dedication and clear skies rather than institutional funding. The search techniques being developed for three I/ATLAS's potential companions are revolutionizing how we look for moving objects in space. Instead of scanning the entire sky uniformly, telescopes are focusing on regions where theoretical models predict incoming streams might concentrate. It's a more targeted approach that could dramatically increase our chances of detecting faint visitors that might otherwise escape notice. These prediction models themselves represent marvels of computational astronomy. Supercomputers trace the gravitational influences of countless stars over millions of years, accounting for stellar motions, galactic rotation, and the subtle perturbations caused by dark matter structures. The calculations require processing power that would have been unimaginable just decades ago, yet they're essential for understanding how cosmic materials flow through our galactic neighborhood. The philosophical implications of these discoveries extend far beyond astronomy. If the galaxy contains natural transportation networks that guide materials between stellar systems, then the universe operates more like a living organism than a collection of isolated islands floating in empty space. Materials don't just scatter randomly into the void. They follow paths that can eventually bring them to other worlds, other systems, other opportunities for the complex chemistry that might lead to life. This vision of cosmic connectivity has begun to influence how we think about our responsibilities as a spacefaring species. If we're part of an interconnected galactic ecosystem, then our activities in space take on new dimensions of meaning. The spacecraft we launch, the materials we scatter, the signals we broadcast, all become part of the galaxy's ongoing conversation, contributions to streams of information and matter that will flow between stars for millions of years to come. The educational opportunities presented by this expanding understanding of galactic structure are transforming how astronomy is taught at every level. Students can participate in real research, analyzing data from cosmic visitors and contributing to humanity's growing map of interstellar highways. The abstract concepts of celestial mechanics become tangible when grounded in the concrete reality of objects we can observe moving through space according to principles we're still learning to understand. Cultural institutions are beginning to explore the artistic dimensions of these discoveries. Museums are developing exhibits that help visitors visualize the invisible structures that connect star systems, while planetariums are creating immersive experiences that simulate journeys along galactic highways. The boundary between science and art blurs when dealing with phenomena so vast and beautiful that they challenge our capacity for comprehension. The story of 3I/ATLAS has become more than an astronomical investigation. It's evolved into a meditation on connection and discovery, on the patient process by which humanity learns to recognize patterns that operate on scales beyond our everyday experience. Whether this mysterious visitor travels alone or leads a cosmic caravan, its presence has already enriched our understanding of the dynamic, interconnected galaxy we call home. As telescopes around the world continue their vigilant watch for additional visitors, each night brings new data, new measurements, new pieces of a puzzle that connects our small corner of the cosmos to the vast community of worlds beyond. The gentle rhythm of discovery that characterizes this field of research means that answers will emerge slowly, like stars becoming visible as twilight deepens into night. In the quiet hours between observations, as information streams in from observatories scattered across the globe, there's something deeply peaceful about participating in this cosmic conversation. We're listening to the universe tell its stories through the patient arrival of interstellar messengers, each one carrying tales from distant worlds we'll never directly explore, but can learn to understand through the materials they've chosen to share with us. The mystery continues to unfold, one observation at a time, one calculation at a time, one quiet night of patient watching at a time. Whether 3I/ATLAS is alone or leading a grand procession of cosmic visitors, its journey through our solar system represents something beautiful about the universe we inhabit. A reminder that we're part of a vast, interconnected web of matter and energy that connects every star, every world, every curious observer who looks up at the night sky with wonder. Tonight, as we drift towards sleep with visions of invisible highways and cosmic travelers filling our minds, we can take comfort in knowing that we live in a universe far more organized and connected than we ever dared hope. Somewhere out there, materials from distant worlds are following ancient paths through space, and occasionally those paths bring them to our cosmic doorstep, carrying stories we're only beginning to learn how to read. The search for 3I/ATLAS's companions continues, guided by hope and curiosity, driven by humanity's endless desire to understand the beautiful, mysterious, and endlessly surprising cosmos that surrounds us. In the gentle darkness between discoveries, we can rest knowing that the universe is full of travelers, wanderers carrying messages from distant stars. And sometimes, just sometimes, those messages are meant for anyone patient enough to listen and wise enough to wonder at their quiet revelations. Tonight, as we drift deeper into this celestial mystery, let's explore what the discovery of 3I/ATLAS means for our understanding of cosmic time itself. There's something profoundly moving about realizing that this visitor began its journey long before our species took its first steps, traveling through the galactic dark while entire civilizations rose and fell on distant worlds we'll never know existed. Picture the moment when 3I/ATLAS first broke free from its birth system, perhaps billions of years ago. Imagine the chaotic dance of forming planets, the gravitational ballet that sent countless fragments spinning into the void. Our visitor was just one among millions of such wanderers, each carrying within its frozen structure the chemical signature of its origin world, the isotopic fingerprints of alien stellar fires. The journey that followed defies easy comprehension. While Earth experienced ice ages and extinctions, while the Milky Way rotated slowly through space, 3I/ATLAS drifted through temperatures that hover just above absolute zero. It survived bombardment by cosmic rays, the subtle gravitational tugs of passing stars, encounters with interstellar dust clouds that could have altered its trajectory in ways we're still trying to understand. What makes this timeline even more remarkable is how it intersects with humanity's brief moment of cosmic awareness. For nearly all of 3I/ATLAS's journey, there were no telescopes pointing skyward from Earth, no minds capable of recognizing what it represented when it finally arrived. The visitor has been approaching our solar system for perhaps millions of years, yet it chose to reveal itself during the few decades when we've possessed the tools to appreciate its significance. This cosmic timing feels almost too perfect to be coincidental. Of all the moments in Earth's history when 3I/ATLAS could have passed through our neighborhood, it arrives precisely when humanity has developed the technology to detect interstellar visitors and the curiosity to wonder about their origins. It's as if the universe has been orchestrating this encounter, waiting for us to reach the right level of scientific sophistication before delivering its gift from the stars. The implications of this timing extend beyond mere coincidence, into realms of wonder that challenge our understanding of how discovery unfolds across cosmic scales. Perhaps the galaxy has always been full of such visitors, streams of interstellar objects flowing between star systems in patterns too subtle for earlier generations to detect. We might be witnessing not the beginning of interstellar visitation, but our own coming of age as observers capable of recognizing what has always been there. Consider how this changes our perspective on archaeological discovery here on Earth. When we uncover ancient artifacts buried for millennia, we're finding objects that waited patiently for the right moment of revelation. 3I/ATLAS represents a kind of cosmic archaeology, an artifact from another world that has been approaching our solar system for eons, carrying its secrets across the galaxy until the moment when curious minds were ready to decode its message. The chemistry preserved within this wanderer tells stories that span geological timescales beyond anything we experience on Earth. The isotope ratios locked in its crystalline structure, formed during nuclear processes in a stellar furnace we'll never see, under conditions that existed when our galaxy was younger and perhaps more chaotic than it is today. Every atom in 3I/ATLAS is a fossil from an ancient stellar ecosystem, a sample of cosmic chemistry that unfolded according to physical laws that remain constant across space and time. But there's something even more intriguing about the potential fleet that might be following our cosmic visitor. If additional objects are indeed traveling along similar trajectories, they represent different moments in the same distant star system's history. Some might preserve materials from its youth, when planets were still forming and the stellar environment was rich with the debris of creation. Others could carry signatures of later epochs, when the system had matured and perhaps developed the complex chemistry necessary for organic compounds. This temporal diversity within a single stream of visitors would provide an unprecedented opportunity to study stellar evolution from the inside out. Instead of observing distant stars through telescopes and inferring their histories from spectral analysis, we could hold actual samples from different eras of a stellar system's development. It would be like having a library of cosmic history delivered directly to our laboratory benches, each volume representing a different chapter in the biography of an alien sun. The technology required to decode these temporal messages pushes our analytical capabilities to extraordinary limits. Techniques developed for studying terrestrial geology must be adapted to work with materials that formed under completely alien conditions. Instruments designed to measure isotope ratios in Earth rocks must be recalibrated to detect signatures that might not exist anywhere in our solar system. The precision required is staggering to contemplate. We're attempting to read stories written in atomic nuclei, to extract information from crystal lattices that formed around different stars, to understand chemical processes that occurred before our sun was born. Each measurement must account for millions of years of cosmic weathering, for bombardment by interstellar radiation that might have altered the very signatures we're trying to detect. Yet there's something beautifully poetic about this quest to understand deep time through the study of cosmic wanderers. We're not just analyzing rock and ice, we're decoding messages from the past, reading letters written in the language of stellar nuclear synthesis and delivered by the patient postal service of galactic gravity. Every spectral line reveals something about conditions that existed when the universe was younger. Every isotope ratio tells us about nuclear processes that shaped the chemistry of distant worlds. The international collaboration required for such detailed analysis creates networks of cooperation that span the globe. Laboratories in different countries specialize in different aspects of the investigation, sharing samples and data with the understanding that no single institution possesses all the tools necessary to decode these cosmic messages. The fragments of 3I/ATLAS, if we ever manage to collect them, would become among the most studied materials in human history. Amateur astronomers contribute to this temporal detective story in ways that professional observatories cannot. Their patient observations of brightness variations and rotational patterns help us understand how these objects respond to solar heating, providing clues about their internal structure and composition. The dedication of sky watchers around the world creates a continuous monitoring network that operates across time zones and seasons. The educational implications of studying objects from deep time are transforming how we teach astronomy and planetary science. Students can examine data from materials that predate our solar system, learning about stellar evolution through the concrete reality of samples rather than abstract theoretical models. The concepts of cosmic time and stellar life cycles become tangible when grounded in the study of actual visitors from other eras of galactic history. Cultural institutions are finding new ways to help the public appreciate these vast timescales. Museums are developing exhibits that visualize the journey of interstellar objects across millions of years, while artists are creating works inspired by the idea of cosmic time capsules carrying ancient stories to our modern world. The boundary between science and philosophy blurs when dealing with phenomena that connect us directly to the deep past of our galaxy. The search for additional members of 3I/ATLAS's potential fleet has become a meditation on patience and persistence across cosmic timescales. If theory proves correct and more visitors are indeed following similar paths, they might arrive over periods measured in centuries or millennia. This creates a research program that will span multiple human generations, connecting astronomers across time in ways they never expected. There's something profoundly humbling about participating in investigations that transcend individual human lifespans. The data we collect today might not reach its full significance until combined with observations made by researchers we'll never meet, using technologies we can't yet imagine. We're contributing to a conversation that will continue long after we've returned to the cosmic dust from which we came. The possibility that our solar system regularly receives such temporal messengers changes how we think about our place in galactic history. We're not isolated observers looking out at a static universe, but participants in an ongoing exchange of materials and information that has been operating for billions of years. The iron in our blood, forged in the hearts of dying stars, might have traveled similar paths before finding its way to our world. This perspective transforms the search for 3I/ATLAS's companions into something approaching a sacred duty. We're the first generation of humans capable of recognizing these cosmic time capsules for what they represent, the first to possess the tools necessary to decode their ancient messages. The responsibility to study them carefully, to preserve their information for future generations, becomes a trust we hold on behalf of all humanity. As telescopes continue their patient vigil for additional visitors, each night brings new possibilities for discovery. The gentle rhythm of astronomical observation means that revelations emerge slowly, like photographs developing in a cosmic darkroom. Some questions might be answered within our lifetimes, while others will require the dedicated work of future researchers armed with technologies we can only dream of today. The story of 3I/ATLAS reminds us that the universe operates on timescales that dwarf human experience, while simultaneously connecting us to cosmic processes that have been unfolding since the galaxy was young. Whether this mysterious visitor travels alone or leads a procession of temporal messengers, its presence enriches our understanding of deep time and our place within the vast, slowly evolving story of cosmic history. Tonight, as we drift towards sleep with thoughts of ancient wanderers and cosmic time capsules filling our minds, we can take comfort in knowing that we live in a universe where the past and present intersect in the most beautiful ways. Somewhere out there, materials from the galaxy's youth continue their patient journey toward our solar system, carrying within their crystalline structures the memories of worlds that existed long before Earth learned to dream. The mystery of 3I/ATLAS and its potential fleet continues to unfold across timescales that stretch from the immediate present to the deep future of astronomical research. In the quiet moments between observations, As data accumulates from telescopes around the world, we participate in a form of cosmic archaeology that connects us directly to the ancient history of our galactic neighborhood. Whether 3I/ATLAS leads a fleet or wanders alone, its journey through our solar system represents something profound about the nature of time and discovery in the cosmos. We're not just studying a visiting rock or chunk of ice, we're decoding a message from deep time, reading a letter written in the language of stellar nuclear synthesis and delivered across millions of years by the patient messenger service of galactic gravity. The search continues, guided by curiosity and wonder, driven by humanity's endless desire to understand our place in the vast temporal tapestry of cosmic history. As we close our eyes tonight, we can rest knowing that the universe is full of ancient travelers carrying stories from times we can barely imagine. And occasionally, just occasionally, those stories choose to share themselves with anyone patient enough to listen and wise enough to wonder at their quiet revelations from the deep past of our beautiful, mysterious galaxy. As we continue our gentle exploration of this cosmic mystery tonight, let's drift into perhaps the most profound question that 3I/ATLAS raises about our place in the universe. What does it truly mean to receive visitors from another star system? And how might such encounters reshape our understanding of what it means to be human in an interconnected galaxy? There's something almost mystical about the realization that we're holding conversations with materials that witness the birth of worlds we'll never see. Each measurement we take from 3I/ATLAS, each spectral line we analyze, each calculation we perform, becomes part of a dialogue that spans both space and time. We're not just passive observers anymore. We've become active participants in a galactic exchange that has been unfolding for billions of years. Picture the moment when future researchers might hold actual fragments from 3I/ATLAS in their hands. These wouldn't be abstract data points or distant observations, but tangible pieces of another stellar system that traveled across the cosmic dark to reach us. The weight of such materials would carry more than just physical mass. It would represent the accumulated journey of eons, the patient endurance required to survive passage through interstellar space. The chemistry locked within these cosmic messengers tells stories that challenge our most fundamental assumptions about how stellar systems evolve. When we analyze the isotope ratios preserved in their crystalline structures, we're reading records of nuclear processes that occurred under conditions completely unlike anything in our solar system. The proportions of elements, the traces of radioactive decay, the signatures of stellar winds, all combine to create a chemical fingerprint that's uniquely alien, yet comprehensively scientific. But there's something even more remarkable about the possibility that 3I/ATLAS represents just the beginning of a sustained encounter with materials from the same distant source. If additional objects are indeed following similar trajectories, we might be witnessing the start of humanity's longest-running natural experiment, one that could continue for centuries or millennia as visitor after visitor arrives carrying samples from different regions or epochs of their birth system. Imagine the archives that future generations might build from such encounters. Libraries of cosmic materials, each specimen carefully catalogued and preserved, together forming a comprehensive collection that tells the complete story of how another stellar system formed, evolved, and eventually scattered its children across the galaxy. We'd have actual pieces of alien worlds to study, fragments of moons that orbited distant suns, chunks of asteroids that formed in stellar nurseries we'll never directly observe. The technological challenges of studying an entire fleet of interstellar visitors would revolutionize our approach to space science. Current observatories, impressive as they are, were designed to handle occasional cosmic curiosities, not to monitor and analyze a steady stream of visitors from beyond our solar system. The infrastructure required to study dozens or hundreds of such objects would necessitate advances in both ground-based and space-based astronomy. that stretch far beyond our current capabilities. Consider the rapid response networks that would need to emerge. When telescopes detect a new member of the potential fleet, astronomers would have only months or years to gather comprehensive data before the visitor fades back into the interstellar medium. Teams around the world would coordinate observations with unprecedented precision, sharing telescope time and data in real time to maximize what we could learn from each brief encounter. The development of interception missions becomes not just scientifically valuable but almost morally imperative under such circumstances. If we're truly receiving a procession of samples from another star system, then our responsibility to study them extends beyond mere curiosity into realms of stewardship for all humanity. Future spacecraft might need to be kept in constant readiness, prepared to launch at short notice to rendezvous with newly discovered visitors before they slip away forever. These missions would require revolutionary advances in propulsion technology, matching velocities with objects traveling at dozens of kilometers per second, navigating to targets smaller than city blocks in the vastness of space, collecting samples without contaminating them with terrestrial materials. All represent challenges that push the boundaries of what's currently possible in space exploration. But perhaps the most profound implications would be philosophical rather than technological. If 3I/ATLAS truly heralds the beginning of regular contact with materials from other stellar systems, then humanity's relationship with the cosmos transforms fundamentally. We're no longer isolated on our cosmic island, wondering what lies beyond the vast emptiness that separates us from other stars. Instead, we become part of a connected galactic community where materials, information, and perhaps even the basic ingredients of life flow regularly between stellar systems. The universe reveals itself to be not a collection of isolated islands floating in empty space, but a vast ecosystem where everything influences everything else across distances and timescales that humble human imagination. This interconnectedness becomes even more meaningful when we consider that our own solar system undoubtedly contributes to these galactic streams. Objects ejected from our neighborhood during its chaotic youth are now wandering among other stars, perhaps occasionally visiting distant worlds, where alien observers study them with the same wonder we bring to investigating 3I/ATLAS. We're not just receiving cosmic mail, we're also sending it, whether we realize it or not. The educational revolution that would accompany regular interstellar visitation staggers the imagination. Students around the world could study actual samples from other star systems, examining materials that formed around different types of stars under conditions that exist nowhere in our solar system. The abstract concepts of stellar nucleosynthesis and planetary formation would become tangible realities that could be held, measured, and understood through direct examination. Research institutions would need to develop entirely new fields of study. Comparative stellar archaeology might emerge as researchers learn to read the histories preserved in rocks from different stellar systems. Interstellar mineralogy could develop as we discover minerals and crystal structures that form only under the specific conditions found around certain types of stars. The chemistry of distant worlds would become as immediate and real as the chemistry we study in terrestrial laboratories. The international cooperation required for such comprehensive studies would create bonds between nations and institutions unlike anything we've seen before. When faced with a steady stream of irreplaceable cosmic visitors, each offering limited opportunities for analysis, competition would inevitably give way to collaboration. Data sharing protocols would evolve into something approaching a global nervous system, with observations and insights flowing instantly between research centers regardless of political boundaries. Amateur astronomers would find themselves integral to this worldwide effort in ways that professional astronomy has never experienced. The sheer number of objects requiring continuous monitoring would exceed the capacity of professional observatories alone, making backyard telescopes equipped with modern sensors essential components of a global detection network. The next major discovery might well come from someone pursuing astronomy as a passion rather than a profession. The timeline for such revelations extends far beyond our individual lifetimes into realms that connect us with future generations in unprecedented ways. If 3I/ATLAS is indeed part of a larger stream, the objects following it might arrive over periods measured in centuries or millennia. This means we're potentially witnessing the beginning of humanity's longest-running scientific investigation, one that will require institutional memory and continuity lasting longer than most civilizations. There's something beautifully humbling about participating in research that transcends human lifespans so completely. The observations we make today might not reach their full significance until combined with data collected by our great-great-grandchildren using technologies we can't yet imagine. We're planting seeds of knowledge that will grow in scientific gardens we'll never see, contributing to understanding that will flourish long after we've returned to the cosmic dust from which we came. The cultural impact of regular interstellar visitation would ripple through human society in ways we can barely begin to anticipate. Artists would find inspiration in objects that have traveled for millions of years to reach us, creating works that attempt to capture the profound poetry of cosmic wandering. Writers would craft stories about the worlds these visitors left behind, imagining the stellar systems that gave birth to the materials we study. Musicians might compose symphonies inspired by the rhythm of cosmic arrivals, each movement representing a different visitor from the same distant source. The cadence of discovery, the patient intervals between arrivals, the crescendo of analysis and revelation, all would provide raw material for artistic expression that connects human creativity to the vast symphony of galactic motion. Religious and philosophical traditions would grapple with implications that challenge fundamental assumptions about humanity's place in creation. What does it mean for our understanding of cosmic purpose when we can hold fragments of worlds that formed around different stars? How do we incorporate the reality of galactic interconnectedness into spiritual frameworks that developed when we thought ourselves alone in the universe? The economic implications are equally fascinating to contemplate. Entirely new industries would emerge around the study and analysis of interstellar materials. Technologies developed for space-based sample collection would find applications in fields ranging from medicine to manufacturing. The knowledge gained from studying alien chemistry and geology could revolutionize materials science and lead to innovations we can't currently imagine. Yet perhaps the most profound change would be psychological. Humanity would no longer be able to think of itself as isolated in the cosmos, not because we've discovered intelligent life, but because we've found undeniable proof that we're connected to the broader galaxy through the steady flow of materials between stellar systems. The universe would feel less vast and more intimate, less empty and more alive with connections we're only beginning to understand. The precision required to study these cosmic visitors pushes measurement science toward its absolute theoretical limits. Analyzing samples smaller than grains of sand for isotope ratios that differ by parts per trillion. Detecting organic compounds present in concentrations so minute they challenge the definition of existence. Reading magnetic histories preserved in crystal domains smaller than bacterial cells. These technical challenges would drive innovations that benefit fields far beyond astronomy. Medical diagnostics might advance through techniques developed for detecting trace compounds in cosmic samples. Environmental monitoring could improve through methods created for identifying subtle chemical signatures that survived millions of years in interstellar space. The ripple effects of such research would touch nearly every aspect of human knowledge. The storage and preservation of interstellar samples would become its own highly specialized discipline. Unlike any terrestrial materials, these cosmic visitors would require protection from contamination by Earth-based compounds, while simultaneously being preserved for analysis by technologies that don't yet exist. Future researchers might need to study samples collected decades earlier using instruments we can't currently conceive. International agreements would need to evolve to govern the collection, study, and distribution of interstellar materials. Who has the right to study pieces of another star system? How should such irreplaceable samples be allocated among research institutions? What protocols should govern the preservation of materials for future generations of scientists? These questions would require diplomatic solutions as complex as the science itself. The possibility that some visitors might contain organic compounds adds profound complexity to these considerations. If we discover materials that suggest the chemistry of life might exist in other stellar systems, the implications would extend far beyond pure science into realms of biology, philosophy, and perhaps even theology. Protocols for handling potentially significant organic materials would need to be developed, even if the likelihood of finding actual biological activity remains vanishingly small. As our understanding of interstellar visitors grows and deepens, we might begin to recognize patterns that reveal fundamental information about galactic structure itself. The chemistry and mineralogy of objects from different regions of the galaxy could help us map the distribution of elements forged by different stellar populations. We might learn to read the history of stellar birth and death, written in the atomic composition of cosmic wanderers. The search for three I/ATLAS's potential companions continues to change how we think about our place in the vast community of worlds that populate our galaxy. Each night that telescopes scan predetermined regions of sky, each algorithm that sifts through observational data, each calculation that refines our understanding of orbital mechanics represents a form of cosmic archaeology that connects us to processes operating on scales beyond human comprehension. Whether this mysterious visitor travels alone or leads a grand procession of interstellar messengers, its journey through our solar system has already connected us to something infinitely larger than our local cosmic neighborhood. We're no longer passive observers of a distant universe, but active participants in a galactic ecosystem that operates according to principles we're only beginning to discover. The gentle rhythm of astronomical discovery continues, one observation building carefully upon another, each measurement adding depth to our understanding, while simultaneously revealing new mysteries that will challenge future generations of researchers. In the quiet hours between observations, as data streams in from telescopes scattered around our rotating planet, there's something deeply peaceful about knowing we're part of this ongoing cosmic conversation. Tonight, as we drift towards sleep with thoughts of interstellar highways and ancient cosmic messengers filling our minds, we can take comfort in the knowledge that the universe is far more connected and purposeful than we ever dared imagine. Somewhere out there, materials from distant worlds continue their patient journeys through space, following paths carved by gravitational forces that operate across millions of years, occasionally choosing to visit our small corner of the galaxy and share their stories with anyone curious enough to listen. The mystery of 3I/ATLAS and its potential fleet continues to unfold with each passing night, reminding us that the most profound discoveries often emerge not through dramatic revelations, but through the patient accumulation of knowledge, the gentle persistence of human curiosity, and our endless capacity for wonder at the beautiful, interconnected cosmos we're privileged to call home. The search continues, guided by hope and scientific rigor, driven by humanity's irrepressible desire to understand our place in the vast tapestry of galactic history. As we close our eyes tonight, we can rest knowing that the universe is full of travelers carrying messages from distant stars. And sometimes, just sometimes, those messages are meant for anyone wise enough to recognize them and patient enough to decode their quiet revelations about the magnificent, mysterious, and eternally surprising cosmos that surrounds us all. As we drift even deeper into this cosmic tapestry tonight, let's explore what might happen when the first confirmed companion to 3I/ATLAS finally appears in our telescopes. Picture the moment when an astronomer somewhere in the world notices a faint point of light moving against the stellar background, following a trajectory that matches theoretical predictions made years earlier. The confirmation would ripple through the astronomical community like gentle waves across a still pond. This discovery wouldn't arrive with fanfare or dramatic announcements. Instead, it would emerge quietly through the patient process of orbital calculation and spectroscopic analysis. Days or weeks might pass before researchers could confirm that they were indeed observing the second member of an interstellar fleet, another wanderer from the same distant stellar nursery that gave birth to 3I/ATLAS. The excitement would be subtle but profound. Unlike the explosive joy that accompanies discoveries of new planets or the detection of gravitational waves, this revelation would bring a deeper satisfaction, the quiet fulfillment that comes from seeing theoretical predictions confirmed by observational reality. It would validate not just specific calculations, but our growing understanding of how materials flow through the galaxy on scales that dwarf human experience. Imagine the conversations that would unfold in observatories around the world as this second visitor reveals its secrets. Does its composition match that of 3I/ATLAS, confirming their shared origin? Do subtle differences in their chemistry tell us about conditions in different regions of their birth system? How do their arrival times relate to the gravitational models that predicted when and where such objects might appear? Each measurement would add depth to our understanding, while simultaneously raising new questions. If the two visitors show identical isotope signatures, it strengthens the case for a common origin. But if they display subtle variations, those differences could reveal information about the spatial or temporal distribution of materials in their source system. We might be receiving samples from different epochs in the same stellar system's history, each one preserving chemical signatures from a different phase of planetary formation. The technology required to study multiple interstellar visitors simultaneously would push our observational capabilities in fascinating directions. Telescopes would need to divide their attention between multiple targets, each one demanding continuous monitoring as it traces its path through our solar system. The coordination required between different observatories would create new models for international scientific cooperation. But there's something even more beautiful to consider about the arrival of confirmed companions. It would transform 3I/ATLAS from a cosmic curiosity into the herald of something unprecedented in human experience. We would no longer be studying an isolated visitor, but the first members of what could be a sustained encounter with materials from another world, a decades-long natural experiment delivered to our cosmic doorstep. The implications for our understanding of stellar system formation become staggering when we consider studying not just one or two objects, but potentially dozens from the same source. Each visitor would represent a different sample from the debris disk that surrounded their parent star during the chaotic period of planetary assembly. Some might preserve materials from the inner regions where rocky planets formed, while others could carry ices from the outer reaches where gas giants gathered their atmospheres. This diversity within unity would provide insights impossible to obtain through any other means. We could map the chemical gradients that existed in an alien stellar system, understanding how temperature and stellar radiation influenced the formation of different types of worlds. The mineralogy of inner system visitors might reveal information about the composition of rocky planets we'll never see, while outer system wanderers could tell us about the icy moons and distant comets that populated the frigid reaches of their birth system. The timeline for such discoveries stretches into realms that challenge our normal conception of scientific research. If theoretical models prove correct, new members of the fleet might continue arriving for centuries or millennia, each one adding to our growing library of samples from the same distant source. This creates research opportunities that span multiple human generations, connecting scientists across time in ways that transcend individual careers or lifetimes. Future researchers might inherit observational programs that began before they were born, continuing investigations started by their predecessors while adding their own insights and techniques. The study of interstellar visitors could become one of humanity's longest-running scientific endeavors, a multi-generational quest to understand the nature of stellar systems through the materials they've chosen to share with us. The patience required for such extended investigations reflects something profound about the nature of astronomical discovery itself. Unlike laboratory experiments that can be repeated at will, cosmic research must wait for the universe to provide opportunities. Each visitor offers a brief window of accessibility before fading back into the depths of space, making every observation precious and irreplaceable. There's something deeply meditative about this aspect of the work. Astronomers must maintain vigilance across timescales that dwarf human attention spans, passing their knowledge and techniques to successive generations, while trusting that future researchers will continue the patient accumulation of understanding. It's science as legacy, research as gift to those who will follow. The international cooperation required for such long-term studies is already creating new paradigms for how humanity approaches cosmic mysteries. Data flows freely between institutions, regardless of political boundaries, creating a global nervous system dedicated to understanding our place in the galactic community. The arrival of each new visitor strengthens these connections, reminding us that some questions are too important to be limited by terrestrial divisions. Amateur astronomers continue to play crucial roles in this expanding investigation. Their dedication to continuous observation fills gaps that professional facilities cannot cover, while their passion for discovery often leads to insights that formal research programs might overlook. The next significant breakthrough might well come from someone's backyard observatory, where clear skies and persistent curiosity combine to reveal new secrets about our cosmic visitors. The search algorithms being refined for detecting additional fleet members are revolutionizing how we look for moving objects throughout the solar system. Instead of scanning randomly across the sky, these programs focus on regions where theoretical models predict the highest probability of detection. It's a more elegant approach that conserves precious telescope time, while maximizing our chances of finding faint visitors that might otherwise escape notice. These prediction models themselves represent marvels of computational astronomy that would have been impossible just decades ago. Modern supercomputers can trace the gravitational influences of countless stellar objects over millions of years, accounting for galactic rotation, stellar motion, and the subtle perturbations caused by dark matter structures we can only detect through their gravitational effects. The philosophical implications of confirmed fleet discoveries extend far beyond the technical aspects of astronomical research. If we're truly receiving regular visitors from the same distant stellar system, it fundamentally changes our relationship with the cosmos. We're no longer isolated observers peering out at unreachable lights, but participants in a galactic exchange that operates according to principles we're only beginning to understand. This perspective transforms how we think about materials and information flow throughout the galaxy. The elements in our bodies, forged in stellar furnaces and scattered by ancient supernova, become part of a larger story about cosmic recycling and redistribution. We're made of materials that have traveled vast distances and survived countless encounters, eventually assembling into the complex chemistry that makes consciousness possible. The cultural impact of sustained interstellar visitation would ripple through human society in ways we can barely anticipate. Artists would find inspiration in the rhythm of cosmic arrivals, creating works that attempt to capture the profound poetry of materials, traveling for millions of years to reach our world. Writers would imagine the stellar systems that gave birth to our visitors, crafting stories about worlds we'll never see, but can study through the fragments they've sent us. Educational institutions are already beginning to incorporate these concepts into their curricula, helping students understand that astronomy isn't just about cataloguing distant objects, but about recognizing the deep connections that bind the cosmos together. The story of 3I/ATLAS and its potential companions provides a perfect framework for discussing how scientific understanding evolves, how new observations challenge existing models and lead to revolutionary insights about the universe we inhabit. The precision required to study multiple interstellar visitors pushes analytical chemistry toward its absolute limits. Researchers must detect and measure chemical signatures that might exist in concentrations smaller than anything previously studied, while accounting for millions of years of cosmic weathering that could have altered the very signatures they're trying to identify. These technical challenges drive innovations that benefit scientific fields far beyond astronomy. Techniques developed for analyzing trace compounds in cosmic samples find applications in medical research, environmental monitoring, and materials science. The ripple effects of studying interstellar visitors extend throughout human knowledge, connecting cosmic research to earthbound applications in unexpected ways. The storage and curation of data from multiple interstellar visitors creates its own specialized challenges. Unlike terrestrial samples that can be stored indefinitely, the observational windows for cosmic visitors are brief and unrepeatable. Every photon captured, every spectrum recorded, every measurement taken becomes part of an irreplaceable archive that must be preserved for analysis by future researchers using technologies we can't yet imagine. International protocols for sharing this irreplaceable information continue to evolve as the community grapples with questions that have no precedent in human experience. How long should data be preserved? What formats will remain accessible to future researchers? How can we ensure that the knowledge gained from studying these visitors remains available to all humanity, rather than being restricted to specific institutions or nations? The possibility that additional visitors might contain organic compounds adds profound complexity to these considerations. If we discover materials that preserve the chemical signatures of processes that might occur around other stars, the implications extend far beyond pure astronomy into realms of biology and perhaps even philosophy. The protocols for handling and analyzing such materials would need to balance scientific rigor with the recognition that we might be studying chemistry that represents our first tangible connection to biological processes in other stellar systems. As our understanding of interstellar visitors continues to evolve, we might begin to recognize patterns that reveal fundamental truths about galactic structure and evolution. The chemistry preserved in objects from different regions of the galaxy could help us map the distribution of elements created by different generations of stars, providing insights into how our galaxy has changed over billions of years. The search for three I/ATLAS's companions has already begun to change how we perceive our place in the cosmic community. We're not passive observers looking out at a static universe, but active participants in processes that operate on scales spanning millions of years and thousands of light years. The patient flow of materials between stellar systems connects us to the broader galactic ecosystem in ways our ancestors never imagined possible. Whether three I/ATLAS travels alone or leads a procession of cosmic messengers, its presence has already enriched our understanding of the dynamic, interconnected galaxy we call home. Each night that telescopes scan the predicted arrival zones, each algorithm that processes observational data, each calculation that refines our theoretical models, represents a form of cosmic archaeology that connects us to processes operating on scales beyond individual human comprehension. The gentle rhythm of discovery continues, one careful observation building upon another, each measurement adding depth to our understanding, while revealing new mysteries that will challenge future generations. In the quiet hours between observations, as information streams in from telescopes around our rotating world, there's something profoundly peaceful about participating in this ongoing conversation with the cosmos. Tonight, as we drift towards sleep, with visions of cosmic fleets and interstellar messengers filling our thoughts, we can find comfort in knowing that the universe is far more connected and purposeful than we ever dared hope. Somewhere in the depths of space, additional members of 3I/ATLAS's potential fleet continue their ancient journeys toward our solar system, carrying within their crystalline structures stories from distant worlds that we're only beginning to learn how to read. The mystery continues to unfold with each passing night, reminding us that the most profound discoveries often emerge through the patient accumulation of knowledge rather than dramatic revelations. As we close our eyes tonight, we can rest knowing that the cosmos is full of travelers carrying messages from distant stars. And occasionally, just occasionally, those messages choose to reveal themselves to anyone curious enough to listen and wise enough to wonder at their quiet arrival from the beautiful, mysterious depths of our interconnected galaxy. As we drift toward the end of our cosmic journey tonight, the mystery of 3I/ATLAS continues to unfold in observatories around the world, each new observation adding another piece to a puzzle that may reshape our understanding of the galaxy itself. Whether this enigmatic visitor leads a fleet of interstellar messengers or wanders alone through the cosmic dark, its presence reminds us that we're part of something infinitely larger and more connected than we ever dared imagine. Sweet dreams, fellow travelers.